Hey guys, so on the next section, we're looking at chapter 4-6. This is all about the quadratic formula and the discriminant. So the quadratic formula, you're very lucky. When I was in Algebra 2 at I went to Med High when I was in high school. And when I was in Algebra 2, I was a sophomore. And so I was, 14 years old. Um, they made me memorize this formula, so I'm not going to do that. I'm going to ask you guys to memorize it. I mean, if you memorize it, that's great, but I haven't forgotten it ever since then. Woof, and that was back in 1985, so that's a very long time ago. So anyway, so what is the quadratic formula? Well, another method to try to solve for x, to find your zeros, your roots, your x-intercepts, is to use the quadratic formula. Sometimes it's easier just to do that because it's too hard to complete the square, or it's really hard to try to find your solutions and so on. So you can always use a quadratic formula. What is it? Well, here it is, and I'm not even going to look. I'm going to just recite it. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there, see, I still know it. After how long has it been? Oh my goodness, that was very, very long time ago, right? Over 30 years. So anyway, so what does that mean? Well, when you have a quadratic equation, you take the numbers from the coefficients. So the number in front of the x squared is your a, the number in front of the x is your b, the number that's kind of there by itself is your c, then of course this is equal to 0. That's where you're going to take the numbers and plug in here. So I gave you an example here. So let's try to solve x squared minus 10x is equal to 11. Okay, well, it's not equal to 0, right? It's equal to 11. So let's fix it. So if you notice, what we're going to do here is just move your 11 over. So it was on this side, move it over this side of the equal, and that becomes a negative 11, or subtract it from both sides, whichever method works the same. All right, so then now we start looking. Now you really don't have to look at, other than the fact that it's in order, x squared, the x, and of course the number. Now you look at the coefficients, the numbers in front of the letters, or the constant here. So if I don't see a number, there's actually one there. Remember, it's not a 0 because 0 would cancel it. It's the number 1. So there's a 1, negative 10, negative 11. There's my A, there's my B, there's my C. So if it helps for you to do it, just label them. It makes it a lot easier. So now, plug it in. The formula says to take the negative of whatever B is. B is a negative 10. So I got to take the negative of a negative 10. So negative, negative, you know what's going to happen. It's going to turn positive. So if you notice, that's what happened here. All right, so that one's done. Then, look at this. Don't freak out with that. Remember, we've seen it before. It's either the positive or the negative. So it's plus or minus. So just ignore it for right now. Let's continue substituting. The formula says to take your b, the b value, which is at negative 10 now again, but this time I'm going to square it. And if you notice, I did that over here. So let's not get ahead of ourselves. Let's continue with this formula here. And then it says to subtract 4 times a times c. Okay, so I'm going to subtract 4, but first I got to multiply it by a, which is 1, and by c, which is negative 11. There they are. All of that is going to go on top of 2 times, and the formula says 2 times the letter A. And A is 1, so 2 times 1, that's easy. Your denominator is going to end up being 2, because 2 times 1 is 2. All right, so now let's clean this up. Whoa, it looks like a hairy monster, but it's okay. We'll tame it down step by step. All right, so negative, negative, we already says turns positive, plus or minus the square root of, well, what's negative 10 squared? That's 100. So there it is, 10 times 10, 100. Negative 10 times negative 10, 100. Now, this ugly thing here. Well, I have a negative and a negative over here. That's going to turn positive because negative times negative is positive. So 4 times 1 is 4. And it was negative 4 times negative 11 becomes a positive 44 anyway. So there it is. So now inside the square root, I've got 100 plus 44 is 144. So I either do 10 plus or minus the square root of 144. And so it's all of that's divided by 2. Well, that's easy. Remember, the square root of 144, most of you memorize it in elementary. It's 12, and if not, just use a simple calculator to get that, because 12 times 12 is 144. So what do I got to do? 10 plus or minus the 12 divided by 2. So let's do the two pieces. What if I do 10 plus 12? Isn't that 22, right? 10 minus 12, that's negative 2. So I already did the top parts, and now both of them have to be divided by 2. So 22 divided by 2 is 11, so that's one answer. And negative 2 divided by 2 is negative 1. That's another answer. So for this particular equation, if I wanted to graph it, where does it cross the x-axis? What are your zeros? What are your roots? Right here. The parabola is going to cross at negative 1 and positive 11. Simple as that. Now, I want you to notice something. I want you to notice this thing here inside the radical, that, that root symbol. If you notice this right here, b squared minus 4ac, that has a special name. It's called the discriminant. The expression b squared minus 4ac from that quadratic formula can help us to determine how many roots you're going to have, okay? So check it out. If this number in here, all right, so it turned out, in our case, it turned out to be 144. If b squared minus 4ac is greater than 0, so would you say that's the case? Yes, because 144 is greater than 0. Then b squared minus 4ac is a perfect square. Is it a perfect square? Yeah, because I get the square root of 144 is 12, right? So if it's a perfect square, guess what you're going to end up with? 2 real rational roots, okay? So you're actually going to have your guaranteed 2 roots, okay? So that's done. Now, what if the case that this number in here was greater than 0, but it's not a perfect square? What if the number inside here, let's say, is 14? Well, if it's 14, you are going to have 2 real numbers, right? But they're going to be irrational. Remember, irrational roots. So it's going to be like a decimal, right? You're not going to be able to write them as a ratio or like a fraction like that. So that at least you have an idea, but you will get the 2 real roots. Now, what if that thing in here, this number right there, what if it wasn't 144? What if here I got a 0? What if this had been 100 minus 100 or something, just as an example? Whoa, 100 minus 100, that's 0. If this was a 0 right here, check it out, then you would only have one rational root. So one root number that you could write as a ratio, as a fraction, right? So not too bad. And check this one out. If b squared minus 4ac is less than 0, wait a minute, what kind of numbers are less than 0? The only numbers less than 0 are the negatives. What if this was negative 2 inside here? Negative 2. Well, that would be this case. What would you end up with? Look at that. 2 complex roots. Remember, complex, that's imaginary. So going back to that I factor that we were looking at. So, wow, look at this. That's why it's called a discriminant. It discriminates. It gives us a lot of information based on whatever numbers are inside there. So if you end up with a negative, it's like, oh, darn. I mean, you can still do it, but you know now that it's not something you can see. It's not going to be x is equal to some number you can plot, because it's going to be a complex number, which imaginary, right? So notice how the discriminant is super, super important, because it will tell us a lot of information. Write down these notes. That way you have that when you're actually doing the problems. So let's go look at the packet. Here we go. So we've got your packet, and in there you can see this is section 4-6, quadratic formulas and the discriminant. So it gives you the information that I just showed you in the notes. So pretty much kind of the stuff that's here, it's what's in your notes. So just kind of review it again. It gives you an example, so you can practice that example, see if you get the same answer. And then it gives you another example here to practice using the quadratic formula, just like I demonstrated. So notice how they did the exact same thing I did. You could end up with a positive root or a negative root, and so you make sure you attend to those as you're doing these questions. And then, of course, you find the solutions based on whatever you have to do there. So basically, just you follow the example just like I was showing you in the notes, and you should be fine. Now, then the next page of example starts with looking at showing you about the discriminant, right? And so that magical, thing under the radical, the b squared minus 4ac part, right? And so look at the examples that they're asking you to do. So they want you to solve, but by using the quadratic formula. But after a while, you're going to start noticing the discriminant turns into a certain number. Like this one is a square root of 28. So remember some of those rules that we saw in the notes where, yeah, it's greater than 0, but it's not a perfect root. So then, there's some other things are going to happen. You're going to end up getting 2 roots, right, for sure. And if you notice the picture, yeah, look at that. I can see there's 1 root, 2 roots. But there you may get some kind of a decimal answer, right, and stuff. So, just kind of do the problems and so you can practice. Then there's the case where, look at this. Here we are. The discriminant ended up being negative 16. Well, that's nothing to panic about anymore, because in Algebra 1, you pretty much stop there. It's like, oh, we can't do it. It's a negative. We got to stop there. But this is Algebra 2. Now you're learning the second part of the story. Well, back then you couldn't do it because you didn't have enough mathematic tools. Now you do. Now you know about imaginary numbers. So look what they did here. Isn't this like the square root of negative 1 times the square root of 16? Square root of 16 is 4, and the square root of negative 1 is I. So this is actually 6 plus or minus 4i. And then you divide both pieces, both of the terms, by 2, and here is your final answer. So again, complex roots, just because it has the word complex doesn't mean they're like super hard. It just means that we're going to be dealing with imaginary numbers. So go ahead and continue looking at the examples that they give you there and learning more about the roots and some properties. Your packet then, slide 32, has some properties of, what method you're using. So are you going to graph it? Are you going to factor? Are you going to use a square? So it kind of gives you a little summary of the things that you've learned in the last sections to help you, like, okay, well, when should I do it? When is it better to use the quadratic formula? Or when should I look at the discriminant? Is that going to help me? Or should I just graph it? Or do I factor? Or do I complete the square? And so on and so forth. So it kind of gives you a little idea, a little summary of that information as well. All right, so then in your study guide and intervention part, you'll have an example here. Here's a quadratic formula. You don't have to memorize it. Lucky you guys, like I had to memorize it, and we had to present in front of the class. It was this formula and some other things that we had to memorize, and then we had a professor as our teacher, and he would ask us to recite, these things that we memorized. So I did pretty good because my memory is not too bad. It was better back then, right? But still, that's kind of one of the things. So let me do one of these for you just so that we can kind of, practice a little bit more. It says to solve the equation using the quadratic formula. Okay, so I'll do that for you. So let me just grab it. Let's do number 3 or any, it doesn't matter really. So I'm just going to go really quick because you have the formula in your notes. You have the formula in this sheet. So in this particular problem, it says, let me just from memory, the quadratic formula. So negative b, so that means I need to take a negative 11 plus or minus the square root of b squared. So that would be this number squared. And 11 times 11, I believe it was negative and negative positive. It's 121. So there's my b squared minus 4 times a times c. So now let's see if I can do that all together. 4 times 1 is 4. And then 4 times 24, that's 16, carry the 1, 96. All divided by 2 times a, and a is 1, so this would be all divided by 2. This becomes a positive, so I'm kind of gonna get rid of it. Let's see if I can get my pencil eraser to activate. There we go. Because negative becomes positive, so if I just write 11, it's understood. Let's see if I can simplify this guy right here real quick. If you think you might make an arithmetic mistake, something simple as just adding or subtracting, which I often do just because, I have so many things going on. So then let me go ahead and activate. Oh, sorry. I think I have to use my clicker. There we go. All right. So I click it one more time. I want just my scratch pad and I just punch that in. So 121 subtract 96 and that should give me 25. So, ooh, nice, 25. Why am I all excited about that? Well, it's a square root, right? Like I could take the square root of 25 and not even use a calculator or anything. So let's see the two pieces here. This is now 11 plus or minus the square root of 25 divided by 2. And I think we all know the square root of 25 is 5. So I actually have 11 plus 5 over 2, and 11 minus 5 over 2. Because in here is just the number 5, and I'm supposed to add or subtract it. So 11 plus 5, 11 minus 5. And there they are. So 11 plus 5 is 16. 16 divided by 2 is 8. So that's one of my possible solutions. So x is either equal to 8, or x could equal to, x equals 2. So 11 minus 5 is 6. 6 divided by 2 is 3. There we go. So these are my two solutions for that particular problem. And see, I just use a quadratic formula. But heck, look at this. I could have also just factored, right? Equal to 0. So let's try, if I had just factored, what would that look like? Well, if I had just factored, you'll remember how I did the factoring. I said, well, what times what equals x squared? X times x. Then you say, what times what equals 24? I'm going to do a shortcut. I already know the answers, right? So I'm just going to say, you know what? To get a 24, I need 8 times 3, right? Well, once you have this, what else do I need? I need to add them. 8 plus 3. 8 plus 3 is 11. Ooh, but I got to be careful, right? What else do I need to do? Well, remember, whenever you're doing these, it's always the opposite. Doesn't this have to be negative and this have to be negative? Because negative 8 plus negative 3 is negative 11, and 8 times 3 is 24. So this, I actually have to make sure I do that. So remember, we had said already the opposite of these is when you have the factors here. So if you have the factors, it's x minus 8, x minus 3 is 0. Why? Because x equals to 8. If I place an 8 right here, 8 minus 8 is 0. Or if I place a 3 right here, 3 minus 3 is 0. So it doesn't matter which one you do, because 0 times this or this times 0 would still give you an answer of 0. So just an extra little piece that you can do just to continue practicing some of the things you already learned.